Hello and welcome. My name is Ray Hall and I'll be presenting to you today. I'm a senior at Southern New Hampshire University studying data analytics and have over 18 years professional experience in information technology and a passion for mining data for actionable insights. For the project that I'll be presenting to you today, I've mined data on over 200,000 loan records, and I'm hoping that my insights that I uncovered in this data will lead to more profitable lending practices for the Lending Club. For today's agenda, we're going to start by defining the business problem. Then I'll present the research questions that really provide the framework for our analysis. Then we'll talk about the proposed analytics solution, which is a multiple linear regression model. Then I will present the data and the results with visualizations. Then we'll talk about the final model, kind of how all of this comes together. With that, we'll make strategic recommendations. How does all of this apply to the business? And then we'll conclude with final thoughts. So as much as we all love looking at data, it really serves us little purpose if we're not doing so in pursuit of solving a business problem, answering a business question, something that's going to be actionable and applicable to improving the business in some way. The data that you see on your screen now represents over 217,000 loans that cover 2007 through 2013. And in terms of business problems, the thing that stood out to me is 14% of the loans represented in the data were not profitable. That accounted for over $205 million in negative revenue. So to me, that's, while 86% of the business is profitable, 14% is a significant portion of the business that I feel like we can attempt to tackle and attempt to reduce those numbers. Just to give you a little more insight into the data, if you look at the loans individually, the minimum profit and minimum loss, as you might expect, were both around $0. The median figures for each, the median profitable loan comes in around $2,000, the non-profitable at $5,000. The average is $3,000 for profitable loans and $6,000 for non-profitable, and the maximum profitable loan came in at a profit of $25,000, and the maximum loss was $35,000. So what we see there is when we lose, we're losing bigger than when we win. So with that, I thought this was a worthy pursuit to try to see if we could use this data and the insights to maybe make a positive impact in terms of negative loans. So the obvious question that raises, how can we reduce the number of loans that result in loss? And that leads us to our three research questions. Our first research question is, which variables have a significant effect on loan profitability? What we hope to understand here is, what is it about either the loan or the borrower that either positively or negatively affect profit? This could be the annual income of the borrower, this could be the grade of the loan, the term of the loan. By answering this question, we hope to understand which levers can we pull to affect profitability, the profitability of the loans we issue. Once we understand which variables affect profit, the next question we need to understand is, what is the impact of each variable on profit? In other words, to what degree does a variable impact profit? Is it a negative impact on profit? Is it a positive impact? And ideally, we want to understand in terms of dollars and cents, what is that impact? Once we understand which variables matter and to what degree they matter, the final question we need to answer is how can we apply these findings to our business strategy? So the way we're going to attempt to answer these questions, at least the first two research questions, is through a technique called multiple linear regression. So what is a regression model? Well, regression is one of the most widely utilized predictive modeling techniques. In essence, multiple regression models establishes a relationship between a dependent variable, y, in our case that is profit, and one or more independent variables, x1, 2, 3, 4, as many variables as we find a relationship between x and y. This could be the loan amount, DTI, etc. Ultimately, the regression model is used to predict the value of y based on your predictive variables. So for our project, we're looking to try to predict profit based on loan type and borrower attributes. So with that, let's dig in. We're going to look at the results and answer research question 1, which variables matter? So, having run our 200,000 plus loan records through our statistical software, JMP, we've determined through our regression analysis that loan amount, grade, loan purpose, annual income, loan term, and DTI have a significant effect on profit. And what we're talking about in terms of significance here is statistical significance, and that's determined through p-values. I don't want to get into a deep dive into statistics here for this presentation, but I do think it's important that you understand what a p-value means and what we're talking about in terms of significance here. A p-value is essentially the probability that a variable is being falsely identified as significant. That's known as a type 1 error in statistics. So our p-values for each of these variables is essentially 0. Each is less than 0.0001. So we're fairly certain that our statistical model has produced variables that indeed have some effect on profit. So we've answered our first research question, which variables have a significant effect on profit. Now we're going to look at what effect each variable has, our second research question. And the way we're going to do that is we're going to go through each variable one by one and look at the regression model's estimated effect that variable has on profit. At the end of this, we will be building up to a final regression model equation. So with each variable that we look at, we're going to kind of visualize what that data looks like within our data set, and we're going to talk about the impact that variable has on profit and build towards that final equation. Okay, so the first variable we're going to look at is loan amount. Loan amount is a continuous variable, and as a quick aside, there are two types of variables that multiple regression models can work with, and that is categorical and continuous. Continuous, such as loan amount, is exactly what it sounds like. It's a counting variable, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Categorical variable, exactly what it sounds like. Categories. Loan term, for example, you have category 1, 36 months, category 2, 60 months. When we're visualizing a continuous variable such as loan amount, a scatter plot is a great way to do that, because what that allows us to do is it allows us to plot every loan record against its profit. So what we're looking at here is each loan. On the x-axis we have loan amount, and the y-axis we have profit. And what you can see is that there is positive and negative loans associated with an increase in loan amount, but with the trend line, the green line that moves from the 0 point from left to right, and it sort of trends up, we can see that that overall there's a positive effect on profit via loan amount. You can also see there's a dark, the green is very dark in the areas close to 0 as it moves out, as loan amount increases. So we're seeing a lot more data points that show an increase in profit as loan amount increases. What our model produced in terms of an estimated effect, so again, that's what we're trying to understand here, is so it's a positive effect. What is that effect? For every dollar lent, the model estimates 11 cents in profit added to the loan. So here's where we're going to start building the equation that we talked about in the previous slide. So let's say that this is a $24,000 loan. We take $24,000 and multiply that by the model's estimate of 11 cents, and we get an expected increase in profitability by $2,640. Next, we're going to look at grade. And grade is a categorical variable. With all of the categorical variables in this analysis, we're going to visualize them using bar charts that look at both average profit per category and average loss per category. As you can see here, with each category, A through G, profit increases and profit decreases. It's really difficult to infer any meaning from that visualization, at least anything that we can apply to the business without some sort of statistical model. This is where statistical models are very valuable. The statistics are able to kind of look at the data and make sense of it in a way that it's just not possible to do through a bar chart or through manual observations. So with that, let's look at the model estimates. Category A and B both have a negative impact on profit. Negative 492 for A and negative 57 for B. C, D, and E are all positive. $115, $147, $255 respectively. And F, again, has a negative impact of $31, and G is neither positive nor negative. Continuing on with our example equation, we've already said that this is a $24,000 loan, and that impact was a positive $2,640. So now we're going to say this is a $24,000 loan that is grade C, which adds another $115 to profit. So now we're looking at $2,755 in profit so far. Okay, now we're going to look at loan purpose. Again, this is a categorical variable, so we're going to look at both average profit for each category and average loss for each category. This is a great example of where, by visualizing the data, there's not a lot we can take from this and apply to the business. What we can see is that the average profit for each category is less than the average loss for each category, but how that tangibly applies to our business is difficult to say. So we leave that to the statistical model. And what we can see here is that Many of the categories have a positive impact, some have a negative impact. And there are probably many reasons that go into each of those. Small business loans, for example, have a significant negative impact, not a statistically significant impact, but a practically significant impact, a negative $1,000 plus. There are probably various reasons for that. House loans, negative $103 impact. Some of this could be that certain loans are less profitable because they tend to be safer, paid back quickly, not a lot of interest, low interest rates, not a lot of fees attached. Others could be less profitable, maybe because they're less likely, more likely to be defaulted on. It's difficult to say, as an analyst on the outside looking in. The subject matter experts in your business would be able to add a lot more context to these numbers, which is a very important thing to do. But just looking at the data as data, this is how it measures out. So when we apply loan purpose to our example loan equation, let's use education as an example. We now have a $24,000 loan, grade C, for the purpose of education. Education takes $228 away from profit. So now our estimate for profitability of this particular loan is $2,527. Here, we're looking at annual income's effect on profit. Annual income is a continuous variable, so we're visualizing this with a scatter plot. As we saw with loan amount, there are positive and negative loans associated with an increase in income. We could also see here that the overall effect appears to be positive. Our trend line shows that the number of green plots seem to outweigh the number of orange plots in an increasing fashion. What we will see, however, is that our trend line seems to be more extreme than what our model estimates. Our model's estimating that for every dollar lent, that less than a penny, 0.003 worth of profit is added to the loan. The trend line appears to be somewhere around double that. Not to dive too deep into the statistics behind the model, but the reason why there are discrepancies like this in what we visualize and what's produced in the model is our visualization is exactly that. We're simply visualizing the data as it is, whereas the model is accounting for sample size, error, and other things to try to make the best prediction going forward. The model isn't simply trying to reproduce what the existing data says. It's trying to predict what the data would look like moving forward. So that's why we see a more extreme impact of annual income on profit in our visualization versus what we're getting out of the model. And that's very, very common. Now, continuing with our sample loan and our equation, we have, again, a $24,000 loan, grade C, purpose education. Now we're going to add the borrower's income of $200,000. That adds $600 to our profit, totaling $3,172. And again, that $600 comes from $200,000 times 0.003. That's our model estimate. That gives us the $600. Now we're looking at loan term. Loan term is categorical, and as with the other categorical variables, we're not able to deduce much practical value out of the visualization. What we can see is that there's a high degree of variability in the 60-month term loans versus the 36, but how we would specifically apply that to the business isn't clear. So if we look at the model estimates, a 36-month term equates to $140 in additional profit, whereas a 60-month adds nothing to the total profit. If we continue on with our example using a 36-month loan, we are looking at adding $140, which now gives us an estimated profit in our sample loan of $3,312. The last variable we'll look at is DTI, debt to income ratio. This is an interesting one. It is continuous, so we're using a scatter plot. And what we see here, if you look at the trend line and the plots themselves, you see a curved relationship. It's not, with our other continuous variables, we had a straight line moving from down to up. This is more of a curved relationship. That's known as a high order effect. And multiple regression is great because it's able to account for higher order effects. And we do that by squaring the variable. So we take DTI, square it, and multiply it by the model's estimate. The estimate in this case is negative 0.3. So if we look at the example equation that we've been building upon, and we use a DTI of 16, we take 16 times 16 and then multiply that by negative 3, and we get a negative impact on profit of 76.8. We've rounded that up to $77. So our estimated profit at this point is $3,235. So here's our final model. The one thing that we haven't discussed yet that's important to include here is you see at the top we have what's called a model intercept. This is essentially the starting value for the model. It's not important that we discuss how we get to that number, but the regression model produces what is essentially a starting point. Then we add in each variable and the model estimate, as you can see here. So now we can take the example we've been working with throughout this presentation, add in the model intercept, which our regression model produced an intercept of negative 476, so that's our starting point. Then we take the loan amount, grade, purpose, annual income, loan term, and DTI figures, build that in, and our profit estimate for this particular loan is $2,759. So I hope you could see the value that this would have to the business. If we're able to apply this model to every loan coming in, that gives us better forecasting. Additionally, we can kind of see how each variable affects profit and build our business strategies around that. So with that, we're going to move on to the final piece of the presentation, which is our strategic recommendations and then our final thoughts. Based on the analysis presented, I recommend the following. First, establish business objectives that are based on the business problem that we've identified. An example could be, let's reduce unprofitable loans from 14% share of the business down to 10% share. Or let's reduce the average loss on an unprofitable loan by 20% from $5,000 to $4,000. Second, Based on the variables identified in the model, establish key performance indicators to support these objectives. So with that, you'll want to incentivize your marketing team, loan approvers, so on and so forth, to make sure you're building your business based on loans that are most profitable. Third, use the regression model to forecast profit. And lastly, apply a decision tree, which is included in the appendix of this presentation. We will not be presenting that here for the sake of time, but it is included, and it will provide you a process and framework by which you can monitor your forecast, make sure your model is working well and is accurate, and gives you some decision points in terms of what if the forecast is inaccurate, what if the model is inaccurate, what if the model is performing well, the forecast is well, but the business is still coming in unprofitable. So that kind of brings all of this together and gives you a process by which you can move forward. So I hope you were able to see the value in this data mining project, in the regression model, and the ability that it offers the Lending Club to better forecast profit, to better understand what impacts profit in the loans that are issued, the types of customers that are most profitable, the types of loans that are most profitable. As an addendum to this presentation, I have included a report that outlines in a little more detail the process that I've taken to come to the conclusions I've come to, the process that went into the analysis, the development of the research questions, so on and so forth. Again, the decision tree model is an appendix on this slide set and is also included in that report. With that, I just want to thank you for the opportunity to be able to dive into your business, look at your data, analyze your data, and hopefully I've produced something of great value to you that can be applied to the business in very short order and to great effect. Thank you.